Chapter 7 WAN Concepts. There are 5 sessions in this chapter. 7.1 The Purpose of WANs. 7.2 WAN Operations. 7.3 Traditional WAN Connectivity. 7.4 The Modern WAN Connectivity. And 7.5 The Internet-Based Connectivity. Without further ado, let's begin. Now let's move to 7.1, the purpose of WANs. Whether at work or at home, we all use the local area networks, the LANs. However, LANs are limited to small geographical area. A wide area network, the WAN, is required to connect beyond the boundary of the LAN. A WAN is a telecommunication network that spans over a relatively large geographical area. A WAN operates beyond the geographic scope of a LAN. In the figure, WAN services are required to interconnect an enterprise's compact network to remote LANs at the branch sites, telecommuter sites, and remote users. WANs may be built by a variety of different types of organizations as follows. An organization that wants to connect users in different locations, or an ISP that wants to connect customers to the internet, an ISP or telecommunications that wants to interconnect ISPs. A private WAN is a connection that is designated to a single customer. This provides the following: the guaranteed service level, consistent bandwidth, and security. A public WAN connection is typically provided by an ISP, or telecommunication service provider using the internet. In this case, the service levels and bandwidth may vary, and the shared connections do not guarantee security. Physical topologies describe the physical network infrastructure used by data when it's traveling from a source to the destination. The physical WAN topology used in WANs is complex and, for the most part, unknown to users. Consider a user in New York establishing a video conference call with a user in Tokyo, Japan. Other than the user's internet connection in New York, it would not be feasible to identify all the actual physical connections that are needed to support that video call. Instead, WAN topologies are described using a local topology. Local topologies describe the visual connection between the source and the destination. For example, the video conference call between the user in New York and Japan would be a logical point-to-point connection. WANs are implemented using the following logical topology designs: point-to-point topology, hub-to-spoke topology, dual-homed topology, fully meshed topology, and partially meshed topology. 7.1.4 Carrier Connections. Another aspect of WAN design is how an organization connects to the internet. An organization usually signs a service level agreement with the service provider, and that's called SLA. The SLA outlines the expected service relating to the reliability and availability of the connection. The service provider may or may not be the actual carrier. A carrier owns and maintains the physical connection and equipment between the provider and the customer. Typically, an organization will choose either a single carrier or dual carrier WAN connection. A point-to-point connection provides a direct logical connection between two locations. It often involves dedicated, leased line connections from the corporate edge point to the provider networks. A point-to-point connection involves a layer 2 transport service through the service provider network. packets sent from one site are delivered to the other site, and vice versa. A point-to-point connection is transparent to the customer network. It seems as there is a direct physical link between the two endpoints. The figure here shows site A and site B are connected directly. It can be very expensive if many point-to-point connections are required. A hub and spoke topology enables a single interface on the hub router to be shared by all spoke circuits. Spoke routers can be interconnected through the hub router using virtual circuits and routed subinterfaces. The figure displays a sample hub and spoke topology consisting of 3 spoke routers connecting to a hub router across a WAN cloud. A hub and spoke topology is a single home topology. There's only one hub router, and all communication must go through it. Therefore, spoke routers can only communicate with each other through the hub router. Consequently, the hub router represents a single point of failure. If it fails, inter-spoke communication also fails. A dual home topology provides redundancy. As shown in this figure, 2 hub routers are dual home and redundantly attached to the 3 spoke routers across a WAN cloud. The advantage of the dual home topology is that they offer enhanced network redundancy, load balancing, distributed computing and processing, and the availability to implement backup service provider connections. These advantages is also pretty obvious. It's very expensive to implement than single home topology. It's because they require additional network hardware, such as additional routers and switches. Dual home topologies are also more difficult to implement because they require additional and more complex configurations. We have fully meshed topology. A fully meshed topology uses multiple virtual circuits to connect all sites. That's described in the figure below. This is the most fault-tolerant topology of the 5 shown. For instance, if the site B lost connectivity to site A, it could send the data through either site C or site D. The last one is the partially meshed topology. A partially meshed topology connects many but not all sites. For example, in the figure, the sites A, B, C are still fully meshed. Site D must connect to site A to reach site B and C. 7.1.4 Carrier Connections. A single carrier connection is when an organization connects to only one service provider, and this picture shows that. The yellow box is one organization site. There are 2 PCs, PC1, PC2 with a router. And an SLA is negotiated between the organization and the service provider. The disadvantage of this design is that the carrier connection and the service provider are both single points of failure. Connectivity to the internet will be lost if the carrier's link or the provider router failed. A dual carrier connection provides redundancy and increases the network availability. As shown in the figure, the connection negotiates separate SLAs with 2 different service providers. The organization should ensure that the 2 providers each use a different carrier. Although it's more expensive to implement, but the second connection can be used for redundancy as a backup link. It could also be used to improve network performance and load balance internet traffic. 7.1.5 Evolving Networks. As a company grows, its network must grow with it. More employees, office, applications, and remote locations create greater demands on the network. A network must support a company's current daily operations, be scalable so it can support future growth, remain reliable and efficient as more users and locations are added, use appropriate technologies, protocols, and service providers, be designed so expansion does not require rebuilding the entire network. To illustrate the differences between network size, we'll use a fictitious company called Span Engineering. And it grows from a small local business into a global enterprise. Span Engineering is an environmental consulting firm and has developed a special process for converting household waste into electricity and is developing a small pilot project for municipal government in its local area. The company initially consists of 15 employees working in a small office. They used a single LAN that was connected to a wireless router for sharing data and peripherals. The connection to the internet is through a common broadband service called the Digital Subscriber Line, the DSL, which is supplied by their local telephone service provider. To support their IT requirements, they contract services from the DSL provider. Within a few years, the company grew and required several floors of a building. The company now requires a campus area network, the CAN. A CAN interconnects several LANs within a limited geographical area. Multiple LANs are required to segment the various departments that are connecting to multiple switches in a campus network environment. The network includes dedicated server for email, data transfer, and file storage, and web-based productivity tools and applications. A firewall secures internet access to corporate users. The business now requires in-house IT staff to support and maintain the network. A few years later, the company expanded and added a branch site in the city, and remote and regional sites in other cities. As shown in the figure, the company now requires a metropolitan area network, the MEN, to interconnect sites within the city. A MEN is larger than a LAN, but smaller than a WAN. To connect the central office, branch offices in nearby cities use private dedicated lines through their local service provider. Offices in their cities and countries require the services of a WAN or may use internet service to connect distant locations. However, the internet introduced security and privacy issues that the IT team must address. Span Engineering has now been in the business for 20 years and has grown to thousands of employees distributed in offices worldwide. To reduce network cost, Span encouraged teleworking and virtual teams using web-based applications, including web conferencing, e-learning, and online collaboration tools to increase productivity and reduce costs. Site-to-site and remote access VPNs enable the company to use the internet to connect easily and securely with the employees and the facilities around the world.